Okay, continuing with section 3.1 on functions. We talked last time about the steps to find the domain of a function given its equation. We're going to first start with all real numbers, make that assumption. Then, if there is a variable in the denominator, we have to exclude any value of the variable that makes the denominator 0. We have to take that out of our domain, so it won't be all real numbers anymore at that point. And if we have a variable under a radical of even index, such as square root, we have to exclude any values for x that would make that radicand negative, because that would be an imaginary number and we need real numbers. So that's our thought process as we go through these examples. Okay, in the first one, we're define the domain and put it in interval and set builder notation. First, start with all real numbers. Next thing, we are to exclude any values of the variable. If there's a variable in the denominator, exclude any values that make it 0. Well, there is. We do have a denominator with variables in it, so we want to, let's just make a note, exclude values that make x squared minus 2x minus 3 equal to 0. Well, how can we find out what those are? Well, let's just solve that, and then that'll tell us what they are, right? So we'll solve that. X squared minus 2x minus 3 equals 0 is a factorable trinomial. X minus 3, x plus 1. So x minus 3 equals 0, and x plus 1 equals 0, x equals 3, and x equals negative 1. What have we found? We have found two values for x that must be excluded from the domain because they would give us a 0 denominator. But everything else, we still have all real numbers. We do not have part 3 where we look for a radical of even index. We don't have that. So this is it. Now, this is telling us all real numbers except negative 1 and 3. We need to write that in interval notation and set builder notation. It might help for interval notation to think about the number line. What we're saying is there are 2 points on this number line that cannot be included, negative 1 and 3, but all other numbers on the number line may be included. So from this, let's look at interval notation. I can have from negative infinity to negative 1, but I cannot have negative 1, so it's an open interval. We use this sort of a capital U to mean union or add that to negative 1 to 3. So any value between negative 1 and 3 is okay, as long as it's not negative 1 and 3. And then I'll union with this last interval 3 to infinity. So these are the values in interval notation that are in the domain for this function. Now, what is set builder notation? We saw this before. The set of all x such that, now I have to describe them. And what do they look like? It's all real numbers x, except x cannot be negative 1, comma, x cannot be 3. And that tells you all what the x's are in the domain. It's all real values of x except negative 1 and 3. Okay. Part B, again, now we start fresh, all real numbers. If there is a variable in the denominator, nope, we don't even have a denominator, okay? So number 2 doesn't apply. If there's a variable under a radical of even index, nope, there's not. So we've done all the questioning. We started with all real numbers, so it's all real numbers. I'll write it in words first. But we need interval notation. How do you write all real numbers in interval notation? That's the whole number line, right? From negative infinity to positive infinity. And in set builder, we can say the set of all x such that x is an element of the real numbers. Any element in the real numbers is in our domain. Okay, so that one had no restrictions on it. Part C, we start with all real numbers. We do not have a denominator with an x in it, but we do have a radical of even index with an x under it. So we have to exclude values that make 3 minus 2x negative. We cannot put in x's that end up with a negative number there. Now, the way when it was the denominator situation, we set it equal to 0 and took those numbers out. When it's the radical situation, we determine what we need. We need 3 minus 2x to be greater than or equal to 0. That way it wouldn't be negative, right? We can have the square root of 0. That'd be fine, wouldn't it? Okay, so that's what we need. So let's just make that happen. We'll solve that. Minus 3, negative 2x greater than or equal to negative 3. Divide by negative 2 and do what? Yes, reverse the sign. So x is less than or equal to negative 3 over negative 2 is positive 3/2. Okay, so the domain for this function is all x's that are less than or equal to, well, got to write it correctly, 3/2. All right, so in interval notation, we have it's closed interval on the highest point and to negative infinity with an open interval. There's our interval notation from negative infinity all the way up to 3/2. And then, of course, set notation is set builder is the set of all x such that, and then we just put this in here, x is less than or equal to 3/2. Okay, so it's a little bit different strategy when it's the radical. We say what we need and we find out what makes that happen. For the denominator, we set it equal to 0, and then these are the numbers we take out. Okay, we'll work the next 3 examples in the next video.